So for problem number 27 from 2.4, we're asked to find a third degree polynomial. So they're telling us find the polynomial function with the leading coefficient of 2 that has the given degrees and zeros. So this is a third degree polynomial. And it has zeros at -2, 1, 4. Okay? So how do we do that? It's not real easy, but then again, it's not too hard. Those are the zeros that we have. And it just has to have a 2 at the beginning of it. So, I guess, where would you guys start? What do we know by looking at this example? How would you find that? What do we know about the zeros? How could I do that? Well, what this is saying is that x is equal to -2, x is equal to 1, and x is equal to 4. Now, if there's zeros, that means that each one of these had to be set equal to 0, right? So now, what that means is x plus 2 equals 0, x minus 1 equals 0, and x minus 4 had to equal 0, right? So to find the 0 of a function, I say 0 equals x plus 2 times x minus 1 times x minus 4, right? The problem is it has a leading coefficient of 2, which means it should have the term 2x cubed as the first term. So let's multiply this out and see what we get. So if I take x plus 2 times x minus 1, I get x squared minus 1x plus 2x minus 2, or x squared plus x minus 2. Is that right? Because you combine the like terms, right? Times x minus 4. So now if I say x squared plus x minus 2 times x minus 4, I get x cubed, x squared minus 2x minus 4x cubed minus 4x, and then positive 8. Is that right so far? You guys with me so far? So then what we're going to do is we're going to combine like terms. So this all becomes x cubed, or cubed. Combine these, I get negative 3x squared. Combine like terms again, I get negative 6x plus 8. Now how do I make that leading coefficient equal 2? Can I take this and multiply both sides by 2? Yes. What's 2 times 0? 0. Now I'm just going to push the 2 through the parentheses using the distributive property. Check my fancy answer book. Guess what? That's the answer. You guys see what I did there? See, the zeros are going to be x equals 2, x equals 1, x equals 4. They're called zeros because they occur when the whole polynomial is set equal to 0. And we know that when we solve a polynomial, we factor, we do prime factorization, and usually we have a series of binomials, and we set the binomials equal to 0. So since we're working backwards, we're going to take x equals negative 2 and set it equal to 0 by adding 2 to both sides. And that gives me x plus 2 equals 0. Same thing here, minus 1 from both sides, I get x minus 1 equals 0. Same thing here, minus 4 from both sides, and I get x minus 4 equals 0. Well, 0 times 0 times 0 equals 0. So this times this will equal 0. The only issue we have is at the very end, because we want the leading coefficient to equal 2, we would multiply everything by 2. By the way, when you multiply 0 by 2, you get 0. So multiplying by 2 doesn't change the fact that those are the zeros. Does that make sense? Okay. That is it.